Namaste. I am Mrs. Arumugalakshmi. Today we are going to discuss the problems in lesson 2 Kinematics of class 11. The first problem. The position vector of the particle has length 1 meter and makes 30 degree with the x-axis. What are the lengths of x and y components of the position vector? So from the diagram you can understand the position of OA vector and the length of OA is given as 1 meter. The angle made by that vector with the x-axis is 30 degree. We have to find the length of x component and y component. From the figure you can see length of x component is nothing but OB and length of y component is nothing but AB. Our aim is to find the value of OB and AB. For that, consider this small triangle OAB. In this triangle OAB, first let us find cos theta. That is cos 30 degree. So cos theta, we know the formula as cos theta is equal to adjacent by hypotenuse. Which is the adjacent side of 30 degree? If you see the diagram, you can find OB is the adjacent. And what is the hypotenuse? Hypotenuse is OA, that is opposite to right angle. Here right angle is formed at OBA or at ABO. This angle is 90 degree. So hypotenuse is OA whose length is given as 1 meter. So cos theta is equal to OB by OA. So OB will be equal to OA cos theta. OA value is 1. Cos theta, theta is 30. So cos 30 value is root 3 by 2. So root 3 by 2 into 1. We know the answer as root 3 by 2. Root 3, the value is 1.732. That divided by 2, the answer will be 0.87 meter. The length of the x component, that is OB value is 0.87 meter. Next, we have to find the length of y component. So, y component, if you see the diagram, AB is the y component. So, for this, we have to once again take the triangle OAB. In the triangle OAB, we have to find sin theta. So, sin 30 is equal to, sin formula is opposite by hypotenuse. So, opposite to 30 is AB. So, AB divided by OA. OA is the hypotenuse. So, AB divided by OA is sin 30. So, from this, you can find the value of AB as AB is equal to OA sin theta. OA value is 1 again from the figure. Theta value is 30 again from the figure. So, 1 into sin 30 is the answer. Sin 30 we know the value as half. So, half into 1. Which is equal to half is the answer. Half means it is 0.5 meter. The length of y component AB value is 0.5 meter. The second problem. A particle has its position moved from R1 vector is equal to 3i cap plus 4j cap to R2 is equal to I cap plus 2j cap. Calculate the displacement vector. Displacement vector we know the symbol as del R vector. And draw the vectors of R1, R2, R vector in a two-dimensional Cartesian coordinate system. So the position vectors R1 and R2 are given as R1 is equal to 3i cap plus 4j cap and R2 is given as I cap plus 2j cap. We know the formula of displacement vector as del R is equal to R2 minus R1. This is the formula of displacement vector. We have to subtract one vector from the other. This is the formula for displacement vector. So, R2 minus R1. R2, we have to subtract the I component with I component, J component with the J component. This is how the subtraction has to be done in vectors. So, in R2, the I component is 1. In R1, the I component is 3. So, 1 minus 3 into I cap plus R2, the J component is 2 and the j component of R1 is 4. So 2 minus 4 j cap. So the answer is minus 2 I cap minus 2 j cap. Minus 2 is in common, so we can take that outside. So del R, which is nothing but the displacement vector, is minus 2 into I cap plus j cap. Now the third problem. Calculate the average velocity of the particle whose position vector changes from r1 is equal to 5 I cap plus 6 j cap to r2 is equal to 2 I cap plus 3 j cap in a time of 5 seconds. So the position vectors are given by r1 vector, r2 vector as 5 I cap plus 6 j cap and 2 I cap plus 3 j cap, and the time is given as 5 seconds. We know the formula of average velocity as del r vector, that is the displacement divided by the time taken. Displacement vector, in the previous problem only we saw the formula as r2 minus r1 is the displacement formula. So r2 minus r1 divided by the time interval, which is given as 5. So r2 minus r1, we have to subtract the two vectors. So if you see R2, it is 2 I cap. First, as I said, you have to subtract the I component with I component and J component with the J component. So here 2 minus 5 I cap plus 3 minus 6 j cap. This is the displacement vector. So 2 minus 5, we know the answer is minus 3, and again 3 minus 6, the answer is minus 3. So the average velocity is given as minus 3 I cap minus 3 j cap divided by 5. Here again minus 3 by 5 is in common. So when you take it outside, we have minus 3 by 5 into I cap plus j cap. This is the value of average velocity. The fourth problem. Convert the vector r1 is equal to 3 I cap plus 2 j cap into unit vector. So the position vector is r1 vector is equal to 3 I cap plus 2 j cap. We have to find unit vector. We know the formula for unit vector as r cap. Unit vector is represented as a cap on the head of r vector. So r cap is equal to r vector divided by mod r. Mod r means the magnitude of r vector. Magnitude means the value. Leaving behind the direction, only value you have to take. That is called as magnitude. So here, leaving behind the direction means the direction in a position vector is represented by I cap and j cap. I cap represents the direction in x-axis, j cap represents the direction in y-axis. Another one we have, which is k cap, which represents the direction in z-axis, but here it is only given in two-dimensional. So leaving behind I cap and j cap, we have to find the magnitude. For magnitude also we have got the formula as mod r is equal to square root of the components. You have to take square root of squares of the component. That will give you the mod value. So here the magnitude is, for I it is 3 and for j it is 2. So the mod r value is square root of 3 square plus 2 square, which is nothing but square root of 9 plus 4, which is square root of 13. Now we have found the mod r value. Now we will substitute in the unit vector. R cap is equal to r vector divided by mod r. R vector is given by 3 I cap plus 2 j cap. It's given in the problem, divided by mod r is square root of 13. This is the value of r cap, or this is called as the unit vector. The fifth problem. What are the resultants of the vector product given by A vector is equal to 4i cap plus 2j cap plus k cap and B vector is equal to 5i cap plus 3j cap minus 4k cap? We know to find the vector cross product, we have to represent it with the determinant formula. The two lines is called as the determinant. So within the two lines, we have to write three rows. First row will be I, J and K. I cap, J cap and K cap. Second row will be the components of the first vector. Here the first vector is A vector, whose components are 4, and next actually here it is minus 2. So first one is 4, next one is minus 2. Then in front of K no number is there, that means that it is 1. So the first row forms 4, minus 2 and 1. It is the second row. First row will be always the same, I, J cap and K cap. The second row will be the components of the first vector. The third row will be the component of the second vector. So second vector is B vector, whose components are 5, 3 and minus 4. So that forms the last row, 5, 3 and minus 4. And already I have taught you how to find the vector cross product. So first for I cap. So I cap is equal to, when you find I cap, you have to hide the row and column in which I is present. So I is present in the first row and the first column. So hide that first row and first column with your two hands. So when you hide it, the remaining will be minus 2, minus 4 and 3 and 1. And here the process of multiplication is, first go on with minus 2 into minus 4. So it will be 8. When you do the next multiplication, you have to change the sign. So it will be minus 2 into minus 4, it is 8. Change the sign. So it will be minus. Now do the multiplication from 3 to 1. So 3 ones are 3. That's all. So I cap into 8 minus 3. Now when you do for J cap, put a minus sign. This is the method. So minus J cap into, you have to hide with your two hands, you have to hide where J cap is there. J cap is there in the first row and in the second column. So these two you have to hide it with your hands. So when you just hide it, the remaining numbers will be 4, 5, 1 minus 4. So here how you should do the multiplication, cross multiplication only. 4 into minus 4, it is minus 16. When you do for the next one, you have to change the sign. So minus 5 into 1, it will be 5. So minus J cap into minus 16 minus 5 plus. Now for the third one, K cap. K cap into, here also you have to hide the row and column in which K cap is present. K cap is again present in the first row and the third column. So with your two hands, just hide the first row and the third column. So the remaining numbers, what you can see, it will be 4 minus 2, 5, 3. As usual, do the cross multiplication. 4 3s are 12. When you do for the second time, you have to change the sign. Minus 5 into minus 2. 5 into minus 2 is minus 10. When you change the sign, it becomes plus 10. So plus K cap into 12 plus 10. Now this is mere addition. So when you do, you will get the answer as 5 I cap plus 21 J cap plus 22 K cap. The sixth problem. Object at an angle such that the horizontal range is 4 times of the maximum height. So an object is projected such that horizontal range is 4 times the maximum height. Here the question is, what is the angle of the projection of the object? We have to find the angle, that is theta, in which it is being projected. So what is the data given? Horizontal range is equal to 4 times H max. This is the projectile question. So already we have derived for projectile what is the formula for horizontal range, what is the formula for maximum height. Already we have learnt in lesson 2. So using those formulas we will proceed. So horizontal range, the formula is u square sine 2 theta by g. Sine 2 theta, we know the formula as 2 sine theta cos theta. So that 2 you bring it to the front. So it will be 2u square sine theta cos theta divided by g. Next, maximum height is given by the formula u square sine square theta by 2g. This is the expression for maximum height. Already we have derived this expression in our class. So, here what is given? Horizontal range is equal to 4 times H max. So, horizontal range we have got one formula. H max we have got one formula. So, substituting these formulas in the first equation, we get 2u square sine theta cos theta by g is equal to 4u square sine square theta by 2g. Here, which all are common in left hand side and right hand side, we are cancelling it out. So what all we can cancel? We can cancel in denominator we have got g. In LHS also g is there, in RHS also g is there. So you can cancel that. Next, in LHS you have got 2u square. In RHS it is 4u square. So u square you can cancel. 2 also you can cancel. The 2 in the LHS will be cancelled with the 4 in the RHS and it becomes 2. In the RHS again numerator we have got 2, denominator 1 2 is there. So all the numerals are cancelled along with u square and g. Now the remaining is sine theta cos theta is equal to sine square theta. Sine square theta is sine theta into sine theta. So 1 sine theta in RHS will get cancelled with the sine theta in the LHS. So the remaining will be cos theta in LHS and sine theta in RHS. So cos theta is equal to sine theta. Now what we are going to do is the cos theta which is in the LHS, I am bringing it to the RHS. So here cos theta is in the numerator. When it comes to the equation this side, it goes to the denominator. So sin theta by cos theta will be equal to 1. What is sin theta by cos theta? It is nothing but tan theta. So tan theta is equal to 1. When tan theta is equal to 1, so theta will be equal to tan inverse of 1. We know the value of tan inverse of 1 as 45 degrees. So the angle of projection only we have to find. So here we have found the angle of projection value theta as 45 degrees. The next problem, 7th one, the following graphs represents velocity time graph. Identify what kind of motion a particle undergoes in each graph. So if you see the first graph, it is a velocity time graph. The slope is constant. Slope means the value of y by x. Y axis we have taken v, x axis we have taken t. So if you find the slope between them, that is v by t, is nothing but the acceleration gives you the value of slope. If you find that is constant. So first graph says you that acceleration is constant. See the second graph. In the second graph, v value is constant. The value of v is constant with respect to time. So what we can say is v is equal to constant for the second one. See the third one. The third one, the slope is greater than the first graph, but it is a constant. So the value of acceleration is again a constant, but whose value is greater than that of the first graph. That is, the acceleration in the third graph is greater than that of the acceleration in the first graph. See the fourth point. In this fourth point, the acceleration is not constant. The slope of the curve is increasing. So, acceleration is a variable. That is, variable means it is the acceleration is keep on changing. That is, the object you can say it is in an accelerated motion. Now, the eighth problem. The following velocity time graph represents a particle moving in the positive x direction. Analyze its motion from 0 to 7 seconds. Calculate the displacement covered as distance traveled by the particle from 0 to 2 seconds. So first we will give an analysis of the graph moving from 0 to 7 second. So first you can divide the graph into 0 to 1.5 second. So in 0 to 1.5 second, if you see the diagram, the object is moving in an opposite direction. After 1.5 to 2, if you see my pointer, the particle is moving with an increasing velocity. Next, see from 2 to 5. 2 to 5, the velocity is constant and you can easily find the value. At what value it is constant? See the corresponding y-axis, the velocity value is 1 meter per second. The constant value is 1, and if you see the graph from 5 to 6 second, the particle's velocity is decreasing, and at from 6 to 7 second, the particle velocity is 0 as the line graces with the x-axis. So we can understand that from 6 to 7, the particle is at rest with 0 velocity. So this is the analysis of the data or graph given. Now we have to find the distance covered by the particle from the graph. Okay, we know that from velocity time graph, how to find the distance. The area under the graph will give you the value of the total distance traveled in a velocity time graph. So first what you have to find is what is the area under the graph. Here we have to find the displacement from 0 to 2 second. So we will just find what is the area covered from 0 to 2 second only. We will limit to 2 second only as it is given in the question. So 0 to 2, you can find two triangle in my diagram. See, this is first, if you just follow my pointer, you can see this is the first triangle and this is the second triangle. Second triangle is just a small one. So the area covered by the particle is given by the area of this first triangle plus area of the second triangle. Area of the triangle, you know the formula as half into base into height. So first triangle area is half into the base value. If you see the base value, this is the base. If you follow my pointer, the base is, and if you can see from the graph, it will be 2. The value is 2 units. So half into 2 and the height is this one. See my pointer, this is the height. It is almost 1.5. So half into 2 into 1.5 is the area of the first triangle. The next triangle, the formula is half into the base. This is the base. If you find the base, it is 1 unit and height is, this is the height. It is just 0.5. So half into 1 into 0.5, this is the area of the second triangle. So when you do the multiplication and when you add, you get the answer as 1.75 meter. This is the distance traveled. For distance, we need not see the direction. Next, what you have to find is displacement. The main difference between the distance and the displacement is the direction. Distance is a scalar, whereas displacement is a vector which includes the direction. So for first, when we were finding the distance, we didn't look upon the direction. But when we were finding the displacement, we have to look upon the direction. See the first triangle is got on the negative axis. So for first triangle area, I have to change the direction as minus. So the calculation will be the same, just the minus sign I have to include since it is got. If you see the triangle itself, if you see my graph itself, you can see the first triangle is got on the negative axis. So I am just putting a minus sign in front of the first triangle area. That is minus 1.5 meter plus the next one is 0.25 meter. It is again in the positive axis, so it is plus 0.25 meter. So the answer is minus 1.25 meter. So minus 1.25 meter is the displacement, whereas the distance travelled is 1.75 meter. See the ninth problem. A particle is projected at an angle theta with respect to the horizontal direction. Match the following for the above motion. So they have given four data: Vx, Vy, acceleration, position vector on one side. On the other side, decreases, increases, remains constant, varies and remains downward. We have to just match. For what? For an object which is projected and it is moving in a horizontal direction. So again move on to the projection. Horizontal projection we have learnt and oblique projection we have learnt. So we have to discuss with the basis of that we have to do this formula. So here Vx, we know that the velocity in the horizontal oblique projection, the velocity in the horizontal projection will be remaining the constant. Here the velocity in horizontal direction is nothing but Vx. So Vx remains constant. Whereas Vy, x-axis only, horizontal only, it will be a constant. Whereas the vertical one or the y-axis, the component of velocity and y-axis will be first it decreases, after that it increases. So Vy is equal to decreases plus increases. And the acceleration will be in the downward direction. You throw any object, it has to come down and it has to reach the ground only. So always the acceleration will be remains downward. And the position vector will be varying. Each and every point the position vector will be varying. So the answer is Vx remains constant, Vy decreases and increases, A value remains downward because the acceleration due to gravity is acting in the downward direction only. So always A will remain downward. Then R, the position vector, keep on varies. That's all. It is a simple problem. The 10th one. A water fountain on the ground sprinkles water all around it. If the speed of the water coming out of the fountain is V, calculate the total area around the fountain that gets wet. So the speed of water is given as V. We have to consider this water sprinkling out of a fountain. If you see the path, see the diagram which is given along with. If you see the diagram, just follow my pointer. It will be in the form of a projectile. So what is the area it reaches? The area it reaches is just the range. In the projectile. In the projectile derivation, we would have find the expression for maximum horizontal range. So the maximum horizontal range will be the maximum area which this water fountain covers. So water comes from a fountain, you can take this as a projectile and the distance covered is the maximum range. Maximum range, we know the formula as maximum range is equal to V square by G sine 2 theta. When it will be maximum, we know that sine 2 theta, when it is maximum, it will be maximum 90 degree only. So 2 into theta is 90 degree means the theta value will be obviously it will be 45 degree. So substituting this, you get the answer as the maximum range of the projectile is V square by G. Here, when you see this maximum range, no, it is V square by G. It is nothing but the area covered by this water which is sprinkled. It will be just in a circle. If you see the diagram below, one circle is given below. So that will be. So circle area, you know the formula as pi r squared. So r, small r is the radius of the circle formed. But this should be the maximum range. So small r is replaced by capital R max. We know the formula for R max, which is V squared by G. Just substituting for R max, we get pi into V squared by G the whole squared. So pi into V squared by G the whole squared will be V power 4 divided by G squared. This is the total area around the fountain. If you know V value, G value, substitute, we can find the area under the fountain which gets wet with the given fountain. The 11th problem. The following table gives the range of a particle when thrown on different planets. All the particles are thrown at the same angle, with the same horizontal and with the same initial speed. Arrange the planet in ascending order according to their acceleration due to gravity. So Jupiter value range is given as 50 meter, Earth is given as 75, Mars is given as 90 meter, the range is given. Mercury it is given as 95 meter. We have to arrange in ascending order according to the G value. So what is the relation between range and the G? We know the formula is range is equal to V square by G. V square sine 2 theta by G. That is, range is in numerator and G is in the denominator. So what is the relationship between range and G? Range is in the numerator and G is in the denominator. That is, one is in numerator and the other, if it is in denominator, the relation between them is inversely proportional. Inversely proportional means range is increasing, the G value will be decreasing. When range is decreasing, G value will be increasing. This is called as inverse proportion. So here range and G are inversely proportional. So what will be the ascending order? The ascending order will be the range which is maximum is Mercury. So for Mercury, the G value acceleration due to gravity, G value will be the least. So ascending order means everyone knows it is from small to big. So Mercury will be the smallest. So Mercury, then it is 90 meter which is Mars, then it is Earth 75 meter, then the last one is Jupiter which is 50 meter. Again a very simple problem. The 12th one. The resultant of two vectors A vector and B vector is perpendicular to vector A and its magnitude is given is equal to half of the magnitude of vector B. Then what is the angle between A and B? So what is given? The resultant of A vector and B vector, the resultant we will have the symbol as R. The R vector is perpendicular to A. So first let us draw the diagram. A vector, if you see my pointer, you can follow the diagram. A vector is given in the horizontal x-axis and B vector is given along y-axis. The resultant of these A and B vector is given as R vector. If you see the angle, it is perpendicular to A vector. And it is given that the magnitude of R vector is equal to half of the magnitude of B vector. So how can we write? Magnitude of R vector is equal to half into B vector. And since they are perpendicular, R vector is perpendicular to A vector, the value angle, we are marking the angle as 90 degree and we are giving a name as alpha. The angle between R vector and A vector is named as alpha and the value of alpha is 90 degree. Okay. So here our aim is to find the angle between A and B. Here in the diagram, this angle is marked as theta and our aim is to find this angle theta. So here what formula we are going to use is, we are going to apply our triangular law of addition of vectors. The two formulas, there we would have done the derivation and two derivations we would have done. That is, one is for the resultant, magnitude of the resultant. The next one is for the direction of the resultant. Both the formulas here we are going to use. First let us use the direction of the resultant formula. In the derivation, this will be the last step. Tan alpha is equal to B sin theta divided by A plus B cos theta. This is the formula. So this formula we are going to use. Tan alpha, here the alpha value is 90 degree. When you see the diagram, you can understand the value of alpha as 90 degree. So tan 90 is nothing but infinity. So infinity is equal to B sin theta divided by A plus B cos theta. We know the value of infinity as, how do we write infinity? Infinity is written as 1 by 0. Anything divided by 0 you call it as infinity. So 1 divided by 0 is equal to b sin theta divided by a plus b cos theta. That is, b sin theta is equal to 1. The numerator we are combining, and the denominator we are combining. Denominator when you combine, you get a plus b cos theta is equal to 0. If a plus b cos theta is equal to 0, you take a that side. It becomes b cos theta is equal to minus a. Now take the b that side. B here it is in multiplication with cos theta. So when it goes that side, it goes as division. So cos theta is equal to minus a by b. Mark this equation and keep. And why no? We are going to substitute this cos theta in our next derivation to find the angle between a and b. So please mark this equation. Next, we are using the magnitude of the resultant formula from triangle law of vectors. It is r squared is equal to a square plus b square plus 2ab cos theta. Here r value, as we have already seen in the question. See the question, read the question again. The magnitude is equal to half of the magnitude of the vector b. Whose magnitude is equal? The resultant vector. So r value is given by b vector divided by 2. Here it is r squared. So b squared by 4 is equal to a square plus b squared plus 2ab. Now only we have seen the value of cos theta as minus a by b. So that value we are substituting here. So when you substitute, what happens? B is in the numerator, b is in the denominator. So we can cancel. You have got 2a. So a into a, it is a square. Minus sign is there. So minus sign you bring it to the front. So it becomes b squared by 4 is equal to a square plus b square minus 2a square. So combining the a square, that is a square minus 2a square, we know the answer is minus a square. So b square by 4 is equal to b square minus a square. Now the b square which is in the RHS, I am taking to the LHS. That is all b on one side, all a on one side. So when you take it, you will have b squared by 4 minus b squared is equal to a square. Here we have to take the LCM and we have to subtract. The simple method you know, do the cross multiplication. So when you do the cross multiplication, it will be minus 3b squared by 4. So minus 3b squared by 4 is equal to minus a square. The 4 which is in the denominator, take it to the numerator. It becomes minus 3b squared is equal to minus 4a squared. The minus sign is common for both. We found minus sign in LHS and RHS. So we can cancel it. So we have 3b squared is equal to 4a square. Now this equation I am going to take square root. Square root on both the sides. That is square root of 3b squared is equal to square root of 4a squared. Square root of 3 is root 3. Square root of b squared is b. Square root of 4 is 2. Square root of a square is a. So you get the equation as root 3b is equal to 2a. So from this find the value of a. So a is equal to root 3b divided by 2. Now we will remind the question of this problem. In the question we have to find the angle between a and b, that is theta. So once again we are coming to this cos theta formula. Cos theta is equal to minus a divided by b, which we have already derived in the first slide. So cos theta is equal to a value, substitute here. So you will have minus root 3b by 2 the whole divided by b. So b you can get cancelled. So cos theta is equal to minus root 3 by 2. So when cos theta is equal to this value, theta will be cos inverse of minus root 3 by 2. And the cos inverse value of minus root 3 by 2 is 150 degree. So the angle between a vector and b vector is 150 degree. The 13th one, this is a very simple problem in this lesson. compare the components of the following vector equation. We have to just compare the I component with I, j with j, k with k. That's all. So see the first equation, t j cap minus mg j cap is equal to ma j cap. So here all the components are j cap. So when you are just comparing, we will just leave that I, j, k and you have to write the equation. That's all. So t minus mg is equal to ma is the answer. See the second equation. In second equation, the vector I cap, j cap and k cap are not given, but instead it is t vector plus f vector is equal to a vector plus b vector. It is understood that t vector has components in both x and y. Similarly, f, similarly a and b. So comparing the x components alone, we have tx plus fx is equal to ax plus bx. Similarly, for y, you can write it as ty plus fy is equal to ay plus by. If you want, you can have it in z component also. Tz plus fz is equal to az plus bz. That's all. Very simple. See, for similarly for the c, we will have tx minus fx is equal to ax minus bx. Here it should be minus bx, or ty minus fy is equal to ay minus by. Here also it should be a minus sign. Similarly, for the last one, t j cap plus mg j cap is equal to ma j cap. When you compare the components, t plus mg is equal to ma. That's all. Comparing the components means leaving behind the I, j and k cap, we have to write the remaining terms. That's all. See the 14th problem. Calculate the area of the triangle for which the two sides are given as A is given as 5i cap minus 3j cap and B is given as 4i cap plus 6j cap. We know the formula of triangle as in terms of vectors. If you see the properties of vector, this is 9th property or 10th property. We have this. Area of triangle is half into mod of A cross B. So mod A cross B, how to find? Already we have seen in one problem. We have to write it in 3 rows. I cap, j cap, k cap will be the first row. Second row will be the component of the first vector. Third row will be the components of the second vector. Here you don't have the k component. So below k you have to write it as 0 and follow the same step. For what is it? We have to hide the, if you are taking the I cap, we have to find I cap is present in which row, which column. You have to just guide and you have to do the remaining multiplication. So when you do that, you will get I cap into 0 plus j cap into 0 plus k cap into 30 plus 12. So it will be, the first two terms will be 0 and finally you will get it as 42 k cap. This is A cross B. So mod of A cross B, modulus value, you know it is the square root of component square. So component is 42, the square is 42 square, we have to take square root. So square root and square will get cancelled. So mod of A cross B is equal to 42. So substitute in the area formula, which is half into mod of A cross B, which is equal to half into 42, which is nothing but 21 meters square. So the area of triangle is 21 meters square. See the 15th one. If Earth completes one revolution in 24 hours, what is the angular displacement made by the Earth in 1 hour? Express your answer in both radian and degree. This is again a simple, very simple problem. That is, the time period of the earth is given as 24 hours. In 24 hours, it goes for one rotation. We know when it goes for one rotation, it goes for a circular path. And what is the angle in a circle? Angle in a complete circle is 360 degree. So, earth covers 360 degrees in 24 hours. That is, 24 hours is equal to 360 degrees. So, 1 hour. Very simple. 1 hour is equal to 360 divided by 24. So you get the answer as 15 degree, or if you want to represent in radian, it is pi by 12. So angular displacement in radian means we have to divide this 15 by 57.295 degrees. So when you just divide this, you can get the radian as 0.262 radian. Already the conversion of radian to degree, degree to radian, already we have discussed in the theory part. So using that formula, you can easily convert. 16th one, an object is thrown with the initial speed of 5 meter per second with an angle of projection as 30 degree. What is the height and range reached by the particle? So maximum height, we know the formula already. We have done a problem regarding this height and range. The h max is given by u square sine square theta by 2g. U value is given as 5. So u square will be 25 into sine square theta. So sine square theta is given as 30. So sine 30 will be half. The square is half full square. So divided by 2 into g. G value is 9.8. So 2 into 9.8. Simplifying this, you get the maximum height as 0.318 meter. Next, maximum range. Range, you know that u square sine 2 theta divided by 2g. U value is 5. So u square is 25 into sine 2 theta. So sine 2 into theta is 30. So 2 into 30 it is 60. Sine 60 divided by 2 into 9.8. Sine 60 you know the value is root 3 by 2. So 25 into root 3 by 2 divided by 2 into 9.8 which is the g value. And simplifying you will get the range as 2.21 meter. So maximum height also we had found. Range also we have found. Again a simple formula. All the problems in second lesson is simple. See the 17th one. A football player hits the ball with the speed 20 meter per second with an angle 30 degree with respect to the horizontal direction as shown in the figure. The goal post is at a distance of 40 meter from him. Find out whether the ball reaches the goal post. Already we have discussed a problem like this in an example when I was taking the theory. So again this is the same problem. So we have to find the range. The range will show you or the range will give you the exact distance covered by the ball. So we know the expression for range as range is equal to u squared sine 2 theta by g. Here the speed value is given as 20. So 20 squared it will be 400. Theta value is given as 30. So sine 2 theta that is 2 into 30 will be 60. And g value you know that it is 9.8. Substituting and simplifying we get the range answer as 35.35 meter. But the goal post is at a distance of 40 meter. So is our projectile, here projectile is nothing but the ball. Is the ball has crossed 40 meter? No, it has crossed just 35 meters only. It hasn't touched this 40. So this ball will not reach the goal post. It will reach the goal post only if the range is greater than 40 or at least it should be 40. Then only it can reach the goal post. So here the answer is the ball will not reach the goal post. Now the 18th one. If an object is thrown horizontally with the initial speed 10 meter per second from the top of the building of height 100 meter, what is the horizontal distance covered by the particle? Here again the range of the object, we know the formula is u into square root of 2h by g. U value is given as 10, h value is given as height of the building as 100. So 2 into 100 it is 200 divided by g. So just simplify, you get the range as 45 meter. This is again a simple formula. Nineteenth one. An object is executing a uniform circular motion with the angular speed of pi by 12 radian per second. At t is equal to 0, the object starts at an angle theta is equal to 0. What is the angular displacement after 4 seconds? So we know the formula. speed is equal to displacement by time. Here it is angular speed. Angular speed means angular displacement by time. Here we have to find angular displacement. So reverse this formula. Angular displacement is equal to angular speed into time. Angular speed is given in the data as pi by 12. Time taken is given. It is asked in the question as after 4 seconds. So the time is 4. So pi by 12 into 4, which is equal to 4 and 12 will get cancelled and you will get the answer as 3. So numerator you have got pi. So the angular displacement is pi by 3, or it is pi is 180. So 180 divided by 3, it is 60 degree. So the angular displacement is 60 degree. This is one more a very simple easy formula. It might be lengthy, but it is a simple one. See, consider the x-axis as representing the east, y-axis the north, and z-axis is vertical upwards. Give the vector representation of each of the following points. First point A is given as 5 meter northeast and 2 meter up. B is 4 meter southeast and 3 meter up. C is 2 meter northwest and 4 meter up. So first we will represent this A, B, C in a direction. We know this is, just follow my pointer, north, south, west, east. So it is given 5 meter northeast. So in northeast we have to draw a line whose length is 5 meter and 2 meter up. It is just 2-dimensional. 3 meter up can't be drawn in a 2-dimensional figure. So 3 meter up it will be in z-axis. And B. See B how it is drawn. It is 4 meter southeast. So southeast is here. Just follow my pointer. It is here southeast. It is 4 meter in the southeast and 3 meter up. Again this cannot be drawn in the diagram because it is a 2-dimensional diagram. And C it is 2 meter northwest. Where is northwest? See my pointer, this is northwest. It is 2 meter and 4 meter up. Again it can't be drawn in the 2-dimensional diagram. So first we have to find the vector representing these two. So first we shall go with the A. So A part alone I have drawn above. If you can follow my pointer, you can understand. A part alone I have drawn here. So this length is 5 meter. This 5 meter line exactly divides the x-axis and y-axis. The angle between x-axis and y-axis is 90 degree. When it is divided exactly by 2, the angle formed will be 45 degree. So here I am drawing, by construction I am drawing a line BA which is perpendicular to the baseline OA. Now take this triangle OAB. So in this triangle we have to find what is cos theta and sin theta. To find, if you remember the very first problem of this slide, we would have found the length along x-axis, the length along y-axis. For that we would have followed the same steps. The same formula and the same method only I am going to apply in the 20th problem. That is, what I have done in the first problem, I am doing the same in the 20th problem. So if you can follow, it will be easy. So when you find in this triangle OBA, if you find cos 45, it will be OA. Cos is adjacent by hypotenuse. So adjacent is OA. Hypotenuse value is given as 5 meter. So cos 45 is OA by 5. From this OA is nothing but the length along x-axis, which is equal to cos 45 into 5. Cos 45 we know the answer as 1 by root 2. So 5 into 1 by root 2 will give you the length of x-axis. Similarly, to find the length of y-axis, we have to find sin 45. Sin 45 is equal to opposite by hypotenuse. Opposite to 45 is AB and the hypotenuse is 5 meters. So sin 45 is AB by 5. Here again we have to find the value of AB. So AB will be sin 45 into 5. So AB is nothing but the length along y-axis, which is 5 into sin 45. Sin 45 is 1 by root 2. So 5 into 1 by root 2, which is nothing but 5 by root 2. This is the length along y-axis. Length along z-axis is already given in the question as 2 meter up. So the value of 2 meter is the length along z-axis. So all the length value we had found. Length is nothing but the magnitude we have found. And you know the vector along x-axis, y-axis and z-axis. What are the three unit vectors along x and y and z? It is nothing but I cap, j cap and k cap. So just putting them all together we get in vector rotation it is 5 by root 2 I cap plus 5 by root 2 j cap plus 2 k cap. This is the vector form of the given direction 5 meter northeast and 2 meter up. So here they have taken 5 by root 2 common in I cap and j cap alone. So if you take, you will be getting 5 by root 2 into I cap plus j cap plus 2k cap. Very simple one. The same what we have done in A, we are going to do for B and C also in the next slides. So it will be the same, just the continuation. See in B, the B form. The B alone I have taken from the diagram and I have drawn above. If you can see, and I have named it as O, A and C. The triangle is O, A and C and the length is 4 meter. Here you have got that 45. By construction I am drawing a line AC which is a perpendicular to OA. So this is the perpendicular one. So opposite to the perpendicular is the hypotenuse. So 4 meters is the hypotenuse. So again in this triangle OAC I am finding cos 45 and sin 45. From cos 45 you can find the length of OA which is nothing but the length of x-axis which is 4 by root 2 meter. Similarly by finding sin 45 you can find the value of length of y-axis which is 4 by root 2 meter again. The length along z-axis is given in the question 3 meter up. So 3 meter is the length of z-axis. So combining them in the vector notation you get 4 by root 2 I cap minus 4 by root 2 j cap plus 3 k cap. Here 4 by root 2 you can take it as common. So you will have I minus j plus 3k. Here if you see, the j component has alone got the negative sign. But in the first case, nothing was negative. But here why j component is alone given a negative direction? If you see the diagram, the j component, that is the y-axis component is lying in the negative axis. So here for j component alone, we are giving a minus sign. Now for the diagram C. C diagram alone I have taken and I have drawn above. The triangle is represented by ODE. By construction I am joining a line DE which is a perpendicular line to OD. So this is 90 degree. Opposite to 90 we have got the hypotenuse whose length is 4 meter. This angle is 45 degree. Again we are finding cos 45 and sin 45 to get the angle, to get the length along x-axis and length along y-axis. The same method if you follow, you will get the length of x-axis as 2 by root 2. 2 can be written as root 2 into root 2. So numerator you have got 2 root 2, denominator 1 root 2. Cancelling it out you will have root 2 meter. So length along x-axis is root 2 meter. Similarly, if you find the length along y-axis, it will be again root 2 meter. So length along z-axis is given in the question as 4 meter. So combining all these things in vector notation, you get minus root 2 I cap plus root 2 j cap plus 4 k cap. Here once again if you find the negative sign is given for the x component. Why it is given for the x component? If you see that x-axis it is lying in the minus negative x-axis. The C value, the C diagram if you see, no, it is lying in the negative x-axis. So for x-axis component alone we are giving a negative sign. That's all. Very simple problem. See the 21st problem. This is once again an easy problem. The moon is orbiting the earth approximately once in 27 days. What is the angle transformed by the moon per day? So the period of moon is, time period is nothing but the time taken by the moon to complete one revolution. So it is 27 days. So in 27 days the moon covers one rotation. That is, one rotation, you know the angle in one circle is 360 degree. So 27 days 360 degree. So 1 day 1 into 360 divided by 27. That is nothing but 360 degree divided by 27. When you divide, you get the answer as 13.3 degrees. Simple problem. The next problem and the final problem of lesson 2 kinematics. An object of mass m has angular acceleration 0.2 radian per second square. What is the angular displacement covered by the object after 3 seconds? What you have to assume is object started with an angle 0 with 0 angular velocity. So initial velocity is given as 0, that we have to assume. Angular acceleration, the symbol is alpha, is given as 0.2 radian per second square. Time is given as 3 seconds. We have to find the angular displacement. We are using our equations of motion, of circular motion. So this is the third equation. So third equation is given by theta is equal to omega naught t plus half alpha t square. You remember the equation of motion of vertical of regular motion, it will be s is equal to ut plus half at square. For linear motion, it will be s is equal to ut plus half at square. The same if you can write for angular motion, it will be theta is equal to omega naught t plus half alpha t square, where omega naught is the initial velocity, theta is the angular displacement, alpha is the angular velocity, t is the time. So substituting the values which are given, omega naught is 0, so the first term becomes 0. So theta is equal to half into alpha value is given as 0.2. So half into 0.2 into t value is given as 3. So t squared, so it will be 3 squared, which is 9. So just putting this value and simplification, we get theta is equal to 0.9 radian, or if you want to represent it in degrees, it will be 51 degrees 54 minutes. So this is the value of angular displacement.